Hi, so now we're going to see the CPU power management circuit. As you can see, CPU power, the VCC core. As you can see, this is the circuit diagram of the CPU circuit, and here in the motherboard, as you can see, this is the CPU and its circuit. So the components around the CPU are the component that is responsible to generate the VCC core. Okay. So here, as you can see, the CPU contains two channels. So here, this is the CPU, as you can see, that we going to study. Here we have two channels, inductors, as you can see, two inductors. Okay, as you can see, every inductor means a channel. And in the back of the CPU socket, we have other components, as you can see. So this is the CPU power management IC here, okay? And this is the MOSFETs, three MOSFETs for the first channel, okay? And the four ceramic capacitors and the other three MOSFETs for the second channel with the four ceramic capacitors, okay? So this is the back of the CPU circuit. As you can see here, many ceramic capacitors and chemical capacitors or polarizer capacitors, as you can see. So this is the power management IC circuit diagram, as you can see. Okay, so this is its part number, as you can see, or reference MAX 8770. Here we have U1018, its reference in the motherboard. So let's see. So you have here U1018, as you can see, the same as we have seen in the schematic. Okay, so this is the power management IC. Here, as you can see, the first channel we have three MOSFETs, and in the second channel, other three MOSFETs. Okay, the same here in the schematic, three MOSFETs in the first channel. As you can see, this is the inductor, and here, this is the second channel. We have three MOSFETs, and we have inductor. Okay, and the purpose is to generate the VCC core. Okay, as you can see, plus VCC core, the main power for the processor. Okay, the VCC core equal about 0.8 volt to 1.2 or 0.3 volts in general. So as you can see here, for the power management IC, in order to generate the VCC core, it should receive some voltage ID. As you can see, this is IDs, as you can see, 8 ID. So this ID determine the appropriate voltage for the CPU. So for every CPU, it has its specific IDs. Okay. So based on the ID, the power management IC can generate appropriate voltage for the CPU. So as you can see here, this is the VCC and the VDD power for the power management IC. Of course, here as you can see, we have the clock, and as you can see, the power grid. So for like every power management IC, it has inputs and outputs. So here, as you can see, we have four ceramic capacitors. This is filtering capacitors. So the 19 volt will pass through these four capacitors and then through these MOSFETs, and then we will get plus VCC core. So this is the four capacitors. This is the four filtering ceramic capacitors, and here we have the three MOSFETs that we have seen in the schematic. Okay, the same here we have four capacitors and three MOSFETs for the second channel, as you can see. Okay, so plus VBAT, as you can see, four ceramic capacitors, filtering capacitor, three MOSFETs. Okay, as you can see, this is gate. Okay, this gate means the control signal should be applied to the MOSFET in its gate. So this is the inductor, as you can see, and here we have the plus VCC core. Here I have a diode. This is a protection component. As you can see, the diode is connected to the ground. If there is a high voltage or a high current, the diode will protect the processor. Okay, the same here as you can see. So we have this MOSFETs, this is gate. These three MOSFETs are activated by the power management IC. Here we have 4 ceramic capacitors. They receive the plus VBAT, the same as the first channel. The plus VBAT is always 19 volt or 20 volt. Okay, and after receiving the control signal from the power management IC, they will generate the VCC core. Okay, so this is the power management IC that generates the control signal for all MOSFETs. So this is the protection diode that is responsible to protect the CPU if there is a high tension or a high current. And the purpose here in this circuit is to get the plus VCC core for the CPU. And as I told you before, every CPU has 8 IDs. Based on the signals, the power management IC know the value of the VCC core. Okay, so now I'm going to show you the component that you should check if you have a bad motherboard and you find that the problem is in the CPU circuit. First component is the charge or the power management IC, and here, as you can see, near to the power management IC we have some ceramic capacitors. These ceramic capacitors connected to the ground in one side and to the power management IC in the other side. So if you find any shorted capacitor, means the power management IC is bad. So this is a technique that you can use to determine whether the power management IC is good or not. Just check the continuity between the terminals of a ceramic capacitor. If you find any shorted capacitor, means the power management IC is bad. And of course you can check the VCC, the presence of the signals, the input signals like VCC, VDD, etc. So you should also check the VBAT, the 19 volt, if it is present or not. You should check the ceramic capacitors because all the ceramic capacitors are connected to the ground, as you can see. So check if these capacitors are good or not. If you find any shorted capacitor, means there is a short. Okay. Then you have to check the MOSFETs. The MOSFETs should be checked. If you find any shorted MOSFET, means the MOSFET is bad. Okay, so you should check the whole MOSFETs and the inductor. The inductor should give a continuity using the multimeter, and also the diode, the protection diode. If the diode is shorted to the ground, means the diode should be replaced. The same for this channel also. You should check MOSFETs, inductor, diode, etc. Okay? Here in the motherboard, as you can see, we have many ceramic capacitors. So we have the IC, should be checked. We have here the ceramic capacitors around the IC. We have the MOSFET, should be checked. Okay? The ceramic capacitors, as you can see, should check it with the ground. Also here in the other channel, you should check the same component. Here we have some chemical capacitors in the back of the socket. You should check it also. If you find any shorted capacitors, means there's a short, you should replace it. Okay. Here we have 2 inductors, as you can see, that you should check. And here we have some capacitors near to the processor.